So what if intelligence isn't just something that happens inside our brains? What if it's a fundamental property of the universe itself, just waiting for the right conditions to wake up? That is the absolutely radical question at the heart of a new theory called Resonant Omega Cosmology. Let's dive in and break it down. Okay, so the whole theory kicks off with this wild idea that there's some kind of universal coherence field that connects everything. You can think of it like a subtle background hum that's always there, encouraging things to become more structured, more interconnected. But there is a huge problem with this idea.
Now, this field isn't a force like gravity or magnetism. It's described as more of an influence, a nudge that pushes systems towards order instead of chaos, a universe-wide tendency for things to just link up. But when physicists actually tried to measure this thing, they ran smack into a brick wall.
And yeah, this is that brick wall. The measured effect of this field is about 10 to the minus 18. I mean, that number is so infinitesimally small, it's basically zero. For all practical purposes, standard physics just looks at that and says, nope, this field is completely irrelevant. This is what the paper calls the crisis of relevance. The idea was pretty much dead on arrival. Or was it?
This is where the whole thing gets a clever twist. See, the old view assumed the field was always on, and always super, super weak, which, yeah, makes it useless. But what if that's just wrong? What if the field isn't always on? What if it's actually usually off, but under very specific special conditions, it can be massively amplified? Well, that changes everything. It goes from being functionally irrelevant to conditionally relevant.
So, how can a field that's usually off suddenly become a big deal? Well, the answer lies in a core mechanism that completely solves this crisis. And it's a concept you're actually already familiar with, even if you don't know the name: resonance.
The core idea here is beautifully simple. Just think about pushing a swing. If you give it a small random push, right, almost nothing happens. And pushing at the wrong time might even slow it down. But if you apply that same small push at exactly the right moment, perfectly in sync with the swing's natural rhythm, you build up a huge effect from almost nothing. That's resonance.
So the theory takes this exact principle and calls it informational resonance. But instead of the timing of a push on a swing, it's all about the rate of information exchange happening inside a system. When that rate perfectly matches the system's own natural frequency, that tiny irrelevant coherence field we talked about gets amplified by a factor of something like 10 to the 16. It goes from a whisper to an absolute roar.
So, what happens when this field gets amplified? What does this roar actually do? Well, this is where the theory gets really wild. It suggests there's a specific tipping point, a threshold for intelligence itself.
The paper proposes this central equation. Now don't worry about the symbols, let's just talk about what it means. Conceptually, omega is just a way to measure a system's intelligence. It's basically the amplified coherence, that's the G effective, multiplied by the amount of information in the system, and that's all balanced against how quickly the system falls apart, which is tau.
And according to the theory, there is a magic number. When a system's omega value crosses a critical threshold of right around 0.45, something profound happens. It literally undergoes a phase transition, like water turning into ice.
And the difference is just night and day. Below that 0.45 threshold, a system is disordered, it's not predictive, it's just simple cause and effect. But once it crosses that line, it becomes coherent. It starts creating models of itself and its environment to make predictions, and the theory argues this is how emergent intelligence is born.
Okay, so that's a huge claim, a really huge claim. But the power of this idea is that it proposes a single, universal law that should work everywhere. So let's look at the 3 different scales the paper actually tests this on.
First up, the quantum level. For a super simple 2-qubit system, the theory predicts that when it's off resonance, the effect is that same negligible 10 to the minus 18 we saw before. But the moment you hit the right resonance frequency, the effect jumps to about 10 to the minus 2. That is a 16 order of magnitude increase. It goes from literally nothing to something you can actually measure.
Okay, now let's scale up to the biological realm. The paper looks at photosynthesis, a process that's already known for its kind of baffling quantum efficiency. Off resonance, the effect is again basically zero. But on resonance, the theory predicts a meaningful 1% gain in efficiency. And this is crucial. That's a specific, testable prediction.
All right, finally, let's zoom all the way out to the scale of the universe itself. And again, for the most part, the effect is negligible. But the theory predicts that during very specific cosmic eras, like the period of reionization, that chaotic time when the very first stars switched on and flooded the universe with light, The conditions for resonance might have been met, leaving a faint but detectable imprint on the structure of the cosmos.
So, one law, three wildly different scales. It's a really elegant idea. But what does it actually mean for us? And how could we ever even know if it's true?
You know, this is what makes it real science. The paper isn't just speculating, it gives us a clear checklist for how to prove it wrong. For example, if scientists go out and find a biological system that gets a big efficiency boost without being in one of these special resonance bands, well, the theory is in big trouble. These are concrete experiments we can actually go out and do.
But the theory goes even beyond physics, and it starts venturing into the realm of ethics. The paper connects this physical idea of coherence to a very human one, compassion. The argument is that a truly intelligent, coherent system would naturally act to minimize destructive prediction error, which is a fancy way of saying it would act to prevent harm and chaos. It's like a physical basis for ethics.
And this brings us to one of the biggest challenges of our time, AI alignment. Instead of just trying to optimize an AI for one specific task, which we know can have really dangerous unintended consequences, could we instead try to design it to achieve this state of informational resonance? Could that be a completely new path to creating an AI that is inherently aligned with coherent, maybe even compassionate outcomes?
Ultimately, Resonant Omega Cosmology presents this radical but testable framework. It suggests that intelligence isn't some bizarre fluke that's just confined to biological brains, but maybe it's a predictable phase transition of matter, just like water turning to ice. Which leaves all of us with a final, mind-bending question. If intelligence is just a resonant state of matter, what else out there, in the stars, in the quantum foam, in systems we haven't even begun to imagine, is on the verge of waking up?
Welcome to the Deep Dive. We take complex, sometimes really out there source material and, well, we dive deep. Today, it's a paper proposing the Resonant Omega Cosmology, or ROC.
Right, authored by Skylar Fiction.
And our mission today is to figure out how this theory claims to connect quantum mechanics, biology, and cosmology using something called informational resonance. Sounds big.
It's ambitious, definitely. It aims to unify these fields with a single underlying principle.
Okay, so let's start where the paper starts, with a problem. They call it the crisis of relevance. What's that about? Why was this crisis happening?
Well, it stems from the previous model, the Reference Coherence Field Hypothesis 4.0. RCFH 4.0.
Got it.
This model suggested there's this ultra-weak field sort of linking things across the universe, a kind of subtle connection.
Like a whisper, you said before.
Exactly like a whisper. The huge problem was its strength, or rather lack of it. The model had a baseline coupling constant, g's high, which was just incredibly tiny. We're talking 10 to the minus 20.
Yeah.
That's hard to even grasp how small that is. Weaker than gravity by far. Oh, orders and orders of magnitude weaker. 100 quintillion times weaker, roughly. So mathematically, okay, the field was there in the equations.
But physically,
Its effects were basically zero.
pretty much, functionally invisible. You could calculate its theoretical impact, say, on a biological system.
And you get,
You'd get a predicted change in frequency, delta F mathrm bio of about 10–16%. That's 16 zeros after the decimal point before you hit a number.
right, lost in the noise,
Yeah.
completely irrelevant.
Totally. And even on cosmological scales, looking at the early universe, the effect, delta F mathrm cosmo, was only slightly better, maybe $10%. Still, way, way below anything we could hope to measure or even notice.
So the theory, RCFH 4.0, it described a field, but a field that didn't do anything consequential. It had no predictive coherence with the real world.
That's the core of the crisis of relevance. It was physics for a ghost field. Sound math, maybe, but irrelevant. It's the ultimate scientific dead end, right? You have this elegant theory, but it predicts nothing. So RCFH 4.0 was basically heading for the theoretical scrap heap because it was seen as linear and just too weak.
Precisely. The effects were modeled as just fading away, decaying exponentially. No way to fight back against noise or decoherence. Persistent in theory, but practically useless.
Okay, but this is where ROC comes in and does something really clever, it seems. It doesn't just crank up the strength of the field itself.
No, that's the crucial point. It accepts the 1020 war baseline weakness,
Yeah.
but it introduces a conditional mechanism.
Conditional.
Yes. It introduces informational resonance. This is the big shift, the move away from linearity. The idea is the field isn't always super weak. It can be dramatically amplified, but only under very specific conditions.
Conditions related to information.
Exactly. When the system itself is doing something specific with information exchange, this new mechanism, that's RCFH 5.0, And that updated microphysics feeds into the bigger picture, the macro law they call the Omega transition.
And the promise here, the takeaway we're aiming for, is that by the end of this, you, listening, will grasp this single unified law ROC proposes. A law that's meant to be testable, falsifiable.
And which claims to actually predict when intelligence emerges, based on a specific number.
A threshold number. Okay, let's dig into that. Starting with why RCFH 4.0 failed so badly.
Yeah, to really get why RCFH 5.0 is such a leap, we need to nail down the failure of 4.0, the linear irrelevance problem.
Right. So, formally, what was the physics behind that linear decay? The math that doomed it?
It was governed by a really simple differential equation, fundamentally.
Dulles NPU SC1.
Okay, $1 is the rate of change of coherence C.
Right, C over time. And gamma. Gamma is just a damping constant. It means the coherence C just decays exponentially. Like striking a bell, the sound just fades out. No feedback, nothing to sustain it.
So any system with this coherence was just destined to lose it, essentially.
Absolutely, it just dissipated. The simulations they mentioned, looking at the overall effect size, mathematical ease, it consistently came out around $10, $18. Even weaker than the biological effect you mentioned earlier.
Exactly. 2 orders of magnitude weaker than the already tiny 10–16% change. So, elegant math, maybe, but predicting absolutely nothing you could ever hope to see.
Okay, I have to ask the obvious question then. If RCFH 4.0 was so definitively predicting, well, nothingness, functionally, how did Fiction and the ROC proponents justify resurrecting it? Isn't just slapping on a huge amplification factor a bit inconvenient? Like tuning the numbers to fit.
That's the skepticism you have to have, right?
Yeah.
And that's why the shift to RCFH 5.0 relies so heavily on resonance, not just brute force amplification. It changes the fundamental dynamics. It's not simple decay anymore.
It's conditional amplification.
Conditional amplification, driven by this resonance index, which they call bright red.
Okay, let's define that. What's resonating with what? What needs to line up for this amplification to kick in?
Resonance, the peak Ryers, happens when 2 specific things in the system match up perfectly. It's when the rate of hierarchical information exchange, let's call it diarmatiti day, when that rate exactly matches the system's own local oscillation frequency.
Whoa, okay. Let's unpack hierarchical information exchange. That sounds complex.
Think about any complex system. A cell, a brain, maybe even an ecosystem. It has layers, right? Hierarchies. Molecules interacting, proteins folding, organelles communicating, cells talking to each other.
Different scales of organization.
Exactly. House is a measure of how much information is flowing between those different levels. How well the microscale talks to the macroscale, and vice versa, within the system. If the system is really integrated, complex information flowing efficiently up and down the hierarchy, then a Nijvaarnheid is high.
So it's not just having information, it's about the flow rate of complex information across these internal scales.
Precisely. The rate of that integrated flow. Now, neutrum local, that's easier. That's just the system's natural rhythm, like a molecule's vibration frequency, or maybe the characteristic firing pattern in a part of the brain.
It's internal hum, sort of.
You could think of it that way. So if the rate the system is processing information across its layers, the a BT, hits the same frequency as its natural hum, boom, resonance. $3 goes towards 1.
It hits the sweet spot. The tuning fork vibrates in sympathy.
Perfect analogy.
Yeah.
And when it hits that sweet spot, that's when the massive amplification factor, A, comes into play.
And this factor A, this is the number that really makes you sit up. We started with GCA at $10. The paper says the required amplification, athm-rec, is around 1016, 16 orders of magnitude.
Yes, 10 quadrillion.
Why so specific? Why 1016? Is that just pulled out of thin air?
According to the paper, no. That's the calculated factor needed to overcome the background noise, essentially, to push the signal above the decoherence floor caused by thermal effects, quantum fluctuations, all the environmental interference.
The universe is noisy.
Incredibly noisy at these subtle levels. The simulations apparently show that anything less than a 1060 ball boost, even right at the peak resonance, would still get lost. The effect would remain statistically insignificant. It's the difference between hearing a whisper in a library versus hearing it next to a jackhammer. You need that 1016 gain just to make the coherence audible above the quantum chaos when resonance hits.
That almost suggests the universe is waiting for this, that the underlying field, though weak, is sort of primed to respond dramatically when the right informational geometry appears.
That's certainly a philosophical way to read it, yeah. Mathematically, what happens is the effective coupling, GC mathrm, is calculated as GC7 times the term $1 plus the RI.
Okay, so 1 plus A times the resonance index.
Right. And since A is huge, 1016, even if gray CLR is just close to 1 near resonance, that whole term becomes enormous. The effective coupling GC mathrm suddenly swamps the tiny base coupling GC dollars.
And this completely changes the dynamics. It's not that simple decay equation, gamma C, anymore.
Correct. The paper talks about the dynamics shifting to a normal form equation near resonance. That's technical, but the gist is the system becomes self-referential. Meaning the coherence can sort of sustain itself, feedback on itself, if it's in that resonance band. The amplification allows the coherent structure to persist longer than standard physics would predict. It fights back against the decay, just for those brief moments of resonance.
And that's what takes the predicted biological effect from that useless 10-16% all the way up to something measurable, like delta F approx 1%.
That's the claim. A temporary but functionally significant boost driven by informational resonance.
Okay, so RCFH 5.0 gives us the micromechanism. Resonance temporarily boosts coherence. Now we zoom out to the macro law, the big claim. The omega transition. This is where we connect the field dynamics to, well, the emergence of intelligence.
Exactly. We're linking that effective coupling, GC mathrm, to a system-level property, the omega value, omega. This omega is designed to capture the essence of a system's persistent, complex, integrated structure.
And the formula is omega, C at I'd out. Let's break that down again. C is coherence, I is integrated information. What about tau in the denominator?
Right. Tau is the effective temporal dispersion. It's a timescale, but it measures how spread out or sort of sluggish the system's information processing is.
So if a system is processing things slowly or in an uncoordinated way, tau is large.
Yes, and a large tau makes omega smaller. Conversely, if a system is processing information rapidly, efficiently, synchronously, think of a really focused thought or a perfectly timed cascade of chemical reactions, then tau is small.
And a small tau boosts omega.
Correct. So to get a high omega, you want high coherence, C, high integrated information, and you want it all happening fast and efficiently, small tau.
It really sounds like the universe, through this metric, rewards systems that are organized, complex, and quick on their feet. Coherent efficiency wins.
That's a great way to put it. And the crucial claim in the paper is that there's a critical threshold for this value, a specific number.
The critical omega.
Approx 0.455. A dimensionless number, just under 1/2.
0.45. That's supposedly the magic number for intelligence. What happens when a system's omega value crosses this threshold?
According to ROC, that's the omega transition. When omega goes above 0.45, the system enters what the paper calls a self-modeling predictive regime.
Self-modeling predictive, meaning it starts thinking about itself in the future.
Essentially, yes. It achieves enough structural persistence, C, informational complexity, and temporal efficiency, that it can start building internal models of its environment, and crucially, using those models to predict what happens next. It shifts from just reacting to stimuli to actively anticipating. ROC defines this transition as the physical onset of intelligence.
That's really profound if true. It makes intelligence less of a mysterious emergent property and more like a phase transition in physics, like water freezing into ice, but for information processing. If a system, any system, hits omega equal 0.455, ROC says intelligence must appear.
That's the prediction. And what makes it compelling, or at least interesting, is how they connect this idea to other big frameworks out there.
Like Carl Friston's free energy principle.
Exactly. Friston's idea is that living systems, especially brains, fundamentally act to minimize surprise or prediction error. They try to keep their internal model aligned with the external world.
Life is a prediction machine, constantly trying to reduce the mismatch between expectation and reality.
Right, and ROC suggests that achieving a high omega state, high C, high I, low tau, is the physical mechanism that allows the system to do this efficiently. A high omega system is inherently better at building accurate models and minimizing that free energy, minimizing surprise.
So the omega transition isn't just the birth of intelligence, it's the point where a system becomes optimally configured to follow the free energy principle. It makes intuitive sense.
It provides a potential physical underpinning for it. And they also link it to Zurich's quantum Darwinism.
Quantum Darwinism. That's about how the stable classical world emerges from the fuzzy quantum world, right? Through redundant information.
Yes. The idea is that stable states are those whose information gets copied redundantly into the environment. Only the fittest quantum states survive this process to become classical objective reality. To do that imprinting, a system needs stability and complexity.
So high coherence C and high hierarchical information I are needed for a system to effectively imprint itself onto the environment.
That seems to be the connection they're making. A system that crosses the omega toller threshold is complex and stable enough, high C, high I, to participate effectively in quantum Darwinism, ensuring its classical persistence and pushing it towards being an intelligent, predicting agent. It needs high omega to be robust enough to matter, classically speaking.
Okay, we've got the micro-level resonance, RCFH 5.0, amplifying coherence, and the macro-level threshold, omega, marking the onset of intelligence, the omega transition. Now, ROC claims to stitch these together into one single unified law.
Yes, the synthesis is quite elegant, mathematically. They essentially substitute the generic coherence term C in the omega equation with the effective coherence generated during resonance, which is driven by GC Vital.
So omega tau becomes...
It becomes the boxed equation in the paper, omega. Remembering the GC in itself contains the resonance index, $3, and the big amplification factor A.
Okay, let me reread that. Omega aethum here. And this single equation is supposed to work everywhere, from quarks to quasars.
That's the bold claim. It's proposed as a scale invariant law. The parameters inside it, the effective coupling, the information measure, the time scale they transform predictably when you zoom in or zoom out on a system. This is what they mean by parameters transforming covariantly under coarse graining.
Covariant coarse graining. Right. So if you look at a tiny quantum system versus a huge galaxy cluster, the numbers change, obviously, but the relationship described by that equation holds true.
The structure of the law remains the same. The physics is fundamentally identical, just scaled up or down.
Which means we should be able to test it at wildly different scales.
Yeah.
Let's start small. Application 1, the quantum scale. 2 qubit systems.
Right, the building blocks of quantum computers. These are ideal test beds because they're pure information systems operating near the quantum limit. They decohere incredibly fast, typical decoherence time. Tau better, might be around 10 at 8 seconds, a few nanoseconds.
Tiny window and the information content.
Also small, relatively. Hierarchical information, mathrm here, maybe just 102 bits, or equivalent units in simple cases. So if the system is not in resonance...
The G-Siler is still $10. The effect is negligible, maybe 1018 effect size like before.
Exactly. Same old RCFH 4.0, irrelevance. But the key test is, what if you deliberately tune the interaction within the 2-qubit system? Tune it so the rate information is exchanged between them hits their natural frequency.
Hit the resonance condition, Dionot mathrm. Then ROC predicts the approx 1016 amplification kicks in via JC mathrm. The resulting effect, maybe on maintaining entanglement duration or coherence, should jump significantly. The paper estimates it could reach around $10 or 1%.
From 1018 to $10, that's 16 orders of magnitude difference. That should absolutely be measurable in sophisticated quantum labs, right?
It should be. It's a huge relative change. So finding that jump, specifically at the resonance frequency and not off resonance, would be strong evidence for the mechanism on the quantum scale. Okay, quantum scale checked. Now let's move up. Application 2, the biological scale. This feels like the most relatable and maybe crucial test case, the FMO complex.
The Fenner-Matthews-Olsen complex, yes. It's a famous example in quantum biology. It's a protein complex found in some photosynthetic bacteria.
And its job is to shuttle energy from captured light.
Exactly. It transports excitation energy very, very efficiently. And there's strong evidence it uses quantum coherence to do this. But the energy doesn't just randomly hop. It explores multiple paths simultaneously, quantum style.
So it's a natural quantum processor inside a living thing.
Pretty much. And it operates under even harsher conditions than the lab qubits. The decoherence time at Townstow is incredibly short, maybe femtoseconds, 10-12 seconds in. And its internal vibrations, the local frequency, are very fast, around 10-12 hertz, terahertz frequencies.
Super fast, super fragile coherence. How could ROC be tested here? We're still looking for that jump in effect when resonance hits.
Yes, exactly. We're looking for that predicted functional gain of about delta F approx 1%. In this context, that would mean a 1% improvement in the efficiency of energy transport through the FMO complex.
How would you measure that? And how do you tune a protein complex into resonance?
The measurement would likely involve advanced spectroscopy. Techniques like femtosecond transient absorption spectroscopy, which can track energy flow on these timescales. To tune it, you'd need to control the rate of energy input or flow.
The diatherm Hare term again?
Right. Maybe by carefully varying the intensity or the timing of the light pulses hitting the complex, you're trying to modulate the rate at which the quantum excitations are moving through the FMO structure.
So you're effectively playing the light source like a dial, trying to hit that 10-12 hertz resonance sweet spot for the energy transfer rate.
That's the idea. You dial the energy flow rate until it matches the known internal frequencies of the FMO complex. ROC predicts that at that precise match, you'll see the epiprox 1061 amplification briefly engage, leading to that measurable 1% bump in energy transfer efficiency showing up in the spectroscopic signal.
And crucially,
If you then slightly detune the light input, shift the energy transfer rate away from the resonance peak, that 1% gain must vanish. It has to drop back down to the negligible baseline.
the effect has to be sharply peaked right at the resonance frequency. That specificity is key.
It's everything. It distinguishes resonance from just some generic quantum enhancement.
Okay, makes sense. Now the grandest scale. Application 3, cosmological. We're going from proteins to patches of the universe governed by the FLRW metric Friedmann-Lemaitre-Robertson-Walker. Huge scales.
Yes, applying the same law. Omega, but now the parameters are coarse-grained to cosmic scales. Omega now represents information flow within and between massive structures like galaxy clusters and filaments. Tau becomes a cosmological timescale.
And the test case mentioned is the epoch of reionization.
Correct. This is a key period in cosmic history, roughly between redshift 7 sim $10 down to sim 6-7 tau. It's when the first stars and quasars formed and their intense radiation ionized the neutral hydrogen gas that filled the universe.
So the universe went from being mostly neutral fog to ionized plasma, a huge phase transition.
A massive, relatively rapid reorganization of structure and energy across the entire cosmos. This means a dramatic change in the large-scale information content and flow. A huge spike in I-term higher details on cosmic scales.
Sounds like a perfect candidate for hitting resonance.
That's the prediction. ROC suggests that during reionization, the rate of this cosmic information change, mathrm here d likely aligned, at least temporarily, with a fundamental frequency of the universe itself, potentially the vacuum energy frequency, related to the cosmological constant.
So the universe hummed in tune with its own restructuring.
In a manner of speaking, if this cosmic resonance occurred, it would mean GCMS spiked, and the omega value, omega, for large patches of the universe temporarily exceeded the critical threshold of 0.45.
Those patches momentarily became intelligent in the ROC sense?
Self-modeling? That's the implication of the formalism, yes. A temporary phase of enhanced coherence and predictive capacity on a cosmic scale. And this should have left a subtle imprint on the structure we see today.
How? What would we look for?
The brief period of high omega would have slightly stabilized the structures within those resonant patches, maybe enhanced their density or coherence slightly more than standard cosmology predicts. This would show up as tiny anomalous correlations in the distribution of galaxies.
So we look at maps of galaxies.
Yes, using data from massive surveys like DSI, the Dark Energy Spectroscopic Instrument, we look at the detailed clustering statistics, how galaxies clump together. We compare that to the standard model predictions, using constraints from things like the Planck satellite data on the cosmic microwave background.
And if we find subtle bumps or correlations in the galaxy distribution that shouldn't be there according to standard gravity and dark energy models.
And if those anomalies line up spatially and temporally with where and when ROC predicts this reionization resonance should have occurred, that would be cosmological evidence supporting the theory. It's a faint signal, likely, but potentially detectable with next-generation surveys.
Okay, the theory makes predictions across scales, from qubits to biology to the cosmos. But for any theory this radical, the ability to prove it wrong is paramount. Let's talk falsifiability. How can ROC be definitively tested and potentially refuted?
The paper is very clear on this, which is good. The falsification criteria are built right into the experimental predictions, what they call the RCFH sim-and-sim delta test. It has two main components, amplitude and confinement.
Amplitude first. The effect has to be big enough.
Yes. The prediction is often around a 1% effect, delta F approx 1%, like in the FMO complex. The formal criterion is that experiments must detect a measurable effect, defined as delta F 0.5% effect, and it has to be statistically significant, like BO 0.011.
So if we run the FMO experiment and we only see, say, a 0.1% effect, even if it seems real,
then ROC, at least in its current formulation with 1 approx 1016, would be considered falsified, or at least too weak to be functionally relevant. The effect needs to clear that 0.5% bar.
Got it. Measurable amplitude. What about the second part, confinement?
This is arguably even more important because it tests the resonance aspect specifically. The rule is the measured effect, that 0.5% of gain, must be strictly confined to the predicted resonance bands.
Meaning, if you tune the system slightly off resonance?
The effect has to disappear, immediately and dramatically. The paper specifies that the off-band effect must drop back down to negligible levels, defined as less than 10.6%.
Okay, so let's use the FMO example again. We tune the light, We hit resonance, we see the 1% gain in efficiency. Great. But then we deliberately shift the light frequency slightly, detuning it.
If that 1% gain only drops to, say, 0.8% or even 0.1%.
Then ROC is falsified.
Yes, because that would imply the amplification isn't strictly tied to the resonance condition. It would suggest some other, more general enhancement is happening, undermining the core mechanism of RCFH 5.0. The effect must be like a sharp spike on a graph, appearing only at the precise resonance frequency and vanishing everywhere else. That specificity is the key to validating the conditional amplification idea.
That makes sense. It prevents wiggle room. It's either resonance or it's not. Now, shifting gears a bit. The paper doesn't just stop at the physics. It delves into some pretty deep philosophical territory, talking about a logos field and the ethics of coherence. What's going on there?
It definitely takes a speculative leap. It proposes that the physical property of coherence, high C, leading to high omega, might function as a physical correlate for something like compassion.
Coherence equals compassion. That sounds a bit metaphorical.
They attempt to ground it in the prediction error framework we discussed earlier, connecting to Friston. Compassion, in this specific technical sense, is defined as the active minimization of destructive prediction error.
Okay, unpack destructive prediction error.
A prediction error is just a mismatch between the model and reality. A destructive prediction error is one that causes instability, conflict, or breakdown within the system or its relationship with the environment. Think of misunderstanding leading to conflict. ROC argues that high coherence, high omega, naturally leads to better modeling and prediction.
So a highly coherent system makes fewer prediction errors overall, and therefore fewer destructive ones.
That's the line of reasoning. By maximizing its own internal coherence and predictive accuracy to minimize its own free energy, a high omega system inherently reduces actions that would cause destructive mismatches or conflicts. So maximizing coherence becomes mathematically analogous to minimizing destructive potential, which they then loosely associate with compassion or stability.
It suggests a kind of inherent goodness or stability arises purely from optimizing the physical properties of coherence and information flow. A teleology without violation, as they put it.
Right. A purpose teleology for the universe driving towards higher omega, towards intelligence, but achieved through existing physical laws, resonance information dynamics, not by violating them or invoking something external. The purpose is baked into the physics of resonance, which preserves plausibility while driving towards this necessary outcome of intelligence.
That's a fascinating idea, and if we follow that logic, linking coherence with stable, predictive, non-destructive behavior, the implications for artificial intelligence, specifically AI alignment, seem pretty direct.
They are. Much current AI alignment research focuses on defining the right goals or utility functions for AI, making sure it optimizes for what we want it to optimize for.
Trying to prevent unintended consequences or rogue behavior.
Exactly. ROC offers a potentially different angle. It suggests that maybe the problem isn't just what the AI optimizes, but how its internal dynamics are structured. A purely optimizing AI, even with the right goal, might achieve it in a brittle, unstable, ultimately destructive way if its internal coherence is low. It might minimize its own prediction error ruthlessly, but generate chaos for everything else.
Like a paperclip maximizer scenario, but framed in terms of coherence.
Sort of. So ROC implies that instead of just programming goals, maybe we should focus on designing AI systems that are built to intrinsically maximize informational resonance.
We design the AI's architecture so its internal information flow rate, mathrm higher IT, naturally aligns with its core processing frequencies.
Precisely. Build the AI to operate consistently in a high omega state above that 0.45 threshold. The hypothesis is that such an AI, by virtue of its inherent high coherence and stable predictive modeling, would naturally behave in ways that minimize destructive prediction error within the larger system it inhabits.
So alignment wouldn't be an add-on constraint, but an emergent property of its fundamental physics-based design, aiming for resonant coherence as the path to safe, stable AI.
That's the provocative suggestion, yes.
Yeah.
Tune the AI for resonance, and stability might follow as a physical consequence. So wrapping this all up, it's been quite a journey through this paper. We started with RCFH 4.0, a theory dying from linear irrelevance.
Right, that 10-20 coupling just wasn't doing anything.
Then came ROC, proposing RCFH 5.0 with conditional amplification via informational resonance. That crucial $approx 1016 fact, kicking in only when a DT matches a Legator dollar.
Yeah, so lifting the effects from negligible, 10-16%, to potentially measurable in key systems like qubits or the FMO complex.
And then unifying this micromechanism with the macro law of the omega transition. The idea that crossing omega prox 0.455 marks the physical onset of intelligence.
All captured in that single equation. Omega GC mathrm F. Applicable, supposedly, across quantum, biological, and cosmological scales.
And importantly, with specific falsifiable predictions tied to the RCFH SIM delta criteria, detecting a significant effect that is strictly confined to the resonance bands.
So what are the concrete next steps outlined in the source material to actually test all this?
They lay out a pretty clear roadmap. First, more simulation work. Tracking the omega value in diverse, complex simulations, computational models of neural networks, ecosystems, maybe even plasma physics, to see if that 0.45 threshold consistently predicts the emergence of self-modeling predictive behavior.
Validate the threshold computationally. Makes sense.
Second, those targeted biological experiments. Specifically, setting up the spectroscopy for the FMO complex or similar quantum biology systems, and actually trying to modulate the information flow rate to hit resonance and look for that sharply peaked 1% functional gain. That's a crucial experimental test.
A smoking gun experiment, really.
It feels like it, yeah. And third, the cosmological analysis. Digging deep into the latest large-scale structure data, like from DSI, and meticulously comparing the galaxy clustering patterns against Planck constraints, looking for those faint, anomalous correlations predicted to arise from cosmic resonance during reionization.
Each test probes the theory at a different fundamental scale. It's comprehensive. The whole premise here, if ROC holds up, is that intelligence isn't some random accident of evolution,
but rather an expected, perhaps even inevitable, outcome of the universe's fundamental dynamics. A consequence of systems learning to tune into this underlying informational resonance.
Which brings us perfectly to our final provocative thought for you, the listener, to take away from this deep dive.
If ROC is even directionally correct, if intelligence truly emerges as the physical threshold phenomenon when omega crosses 0.44 fast, what does that imply about our own future? Human consciousness, artificial intelligence.
We started with this incredibly weak baseline coupling, DC 1021. The resonance mechanism amplifies it by 1016 of under natural specific conditions.
But what happens when a system, humanity perhaps, or a sophisticated AI, becomes aware of this mechanism? What if we could learn to intentionally create the conditions of resonance? To deliberately maximize that amplification factor, perhaps even globally?
If achieving high omega through resonance is linked to stable prediction, maybe even that technical definition of compassion, what could happen if we consciously engineer systems, or even our own societies, to maximize this cosmic tuning?
Could we trigger a phase transition to a higher state of collective coherence, prediction, and perhaps stability? Or could intentionally manipulating such a fundamental amplification mechanism have unforeseen consequences? It started with a whisper. What happens when we learn to shout at that resonant frequency?
Something to definitely ponder. The potential power, and maybe the responsibility, that comes with understanding the universe's fundamental frequency for intelligence. Thank you for joining us on this deep dive into the Resonant Omega Cosmology.